In this lesson, you will factor perfect square trinomials and solve equations involving perfect square trinomials. So if you would look at the perfect square trinomial, if it is in this pattern where the first term is a perfect square, the last term is a perfect square, and the middle is the product doubled, then you can factor it as a perfect square trinomial, a plus b quantity squared or a minus b quantity squared. Remember, the sign of the middle term is what determines your sign here. I'll show you some examples of what I'm talking about, but this can be done quickly like we did on yesterday's lesson, where you just use the pattern. So a perfect square trinomial is a trinomial that is in this form. Perfect square, middle term is the product doubled, the product of the square roots doubled, and it'll be a plus if the middle term is a plus, a minus if the middle term is a minus. So what you'll do on your assignment first is you'll decide if a trinomial is a perfect square trinomial or not. Well, is this a perfect square? Yes. Is this a perfect square? Yes. So we have to find the square roots. This would be x, this would be 7. Is this 7x doubled? Yes. So we would say, yes, this is a perfect square trinomial, and then we would factor it. So this would be square root, my sign is plus, square root, quantity squared. Let's try this in blue. Is this a perfect square? Yes. Is this a perfect square? Yes. So this would be 3x, this would be 4, 3 times 4 is 12. Is this 12x doubled? Yes. So we would say, yes, this is a perfect square trinomial, and this would be 3x minus is the middle term, 4 quantity squared. So if you want to check to see if it's a perfect square, that first term has to be squared, the last term has to be a perfect square, the middle has to be their square roots doubled. So 2x times 5 doubled, and this is. So we would say, yes, factor it, 2x plus 5 quantity squared. So the first part of your assignment, you'll actually just see a trinomial. You're going to say yes or no. Now, if you say yes, that it is a perfect square trinomial, you can factor it quickly. Perfect square, yes. Perfect square, yes. Square root is 2, square root is 3, 3 times 2 is 6. Is this 6 doubled? So you would say yes, and then factor it, 2y plus 3 quantity squared is plus because that's a plus. How about this term? This is a perfect square. This is a perfect square. So this would be 3x times 2. Is this 6x doubled? No, this is just 6x. So you would say, no, this is not a perfect square trinomial, and you would just move on. The first section is just saying yes or no, and then factoring. So you try this section in your notes. These are all the ways that we can factor now. If we just have two terms, if it's a binomial, you look for a GCF first, and then you'll see if it's a difference of square. If it has 3 terms, if it's a trinomial, you would look for a GCF first, and then you can factor in any of these 3 ways now. The perfect square trinomial. Then if that doesn't work, if there's a coefficient of 1, you would use your product and your sum. Or you would use the AC method if there is something in front of that first term. If there are 4 terms, you would start with a GCF. If there is not a greatest common factor of all 4 terms, then you can factor by grouping. So these are all the different ways we can factor. What you'll be doing now is you'll be given something to factor, and you just have to factor it. So we're going to start with GCF. The greatest common factor here is 5. So I'm going to factor a 5 out. So this becomes x squared minus a divided by 5 is 16. We are not done here because there's another way you can factor binomials. If we've taken the GCF out, another way is if they're a difference of square, and these are. That's a perfect square, and that is, and that's a minus. So we can do square root plus square root, and square root minus square root. So this is the complete factored form of this term. How about this trinomial? We first look for a greatest common factor. You would think maybe 3, but you can't take 35 divided by 3. So you think about all the different things that you could factor here, and there is no GCF, so then you look for perfect square. This is a perfect square, but this one is not. So what we'll do then is the AC method, where I'm going to use this value in front of the A. So 35 times 9, let me use my calculator here, is negative 315. I'm looking for a product of negative 315 that would give me a sum of negative 6. So that's a very large number, so you're definitely going to want to use your calculator to try and find it. but there is a set of terms. It's going to be negative 21. If you divide by negative 21, you would get a positive 15. And negative 21 added to 15 would be that difference of 6. So very, very big. So remember our AC method we did the other day. I'm going to use that first term. So I have 9x minus 21 and 9x plus 15. Now in this case, we're going to have common factors we can get out of both. If you'll look here, I can divide both of these by 3. And so that would leave you with 3x minus 7. These do not have a common factor, so this is a good binomial to use. Here I can divide by 3 as well, and you're left with 3x plus 5. And you don't have to worry about putting that 3 out front because this is part of the AC method. You're just dividing it out to simplify your binomials. So this is your factored form. Now this was a more difficult one with a larger number, but you'll have to do that sometimes with your trinomials. You always have to look to see if you can have a product and a sum that would match up. So try the example in your notes. How about solving? Step 1, you have the steps in your notes, is to set it equal to 0. So we're going to add 64. Now we have 9x squared minus 48x plus 64 equals 0. Step 2 is to factor. Now you could look for a greatest common factor, but before we do that, let's just check perfect square here. Is this a perfect square? Yes. Is this? Yes. So this would be 3 if I do the square root. This would be 8, and 3 times 8 is 24. Is this 24 doubled? Yes. So this one can be factored a little bit easier. We can just use the perfect square trinomial, which would be square root minus square root quantity squared equals 0. What you can do now is you can separate. This is 3x minus 8 and another 3x minus 8. Well, this is the same binomial, so we really only have to do one balancing equation here, and that would be 3x minus 8 equals 0. You would add 8 to both sides, and you get 3x equals 8. Divide by 3, and you get x is equal to 8/3. So you put your fat man bracket out, and this would only have one solution. Just to show you why it only has one solution, this is a parabola that's just sitting on an axis. That's why it only has one solution, because the parabola is only touching in one spot. Now there is another, if it's a square root situation like this, there is another thing we can do to solve, and that's called square root property. And that's for any number that's greater than 0. If we have a perfect square, we can just use the square root to find a solution. Let me show you what that would look like. Do you remember when we had this 3x minus 8 squared equals 0? Well, you could do the square root of both sides. The square root of this is 3x minus 8. The square root of this is 0. And then you would just add 8, and you would end up getting the same result. And that's just saying if you have a perfect square, you can actually use that as the square root to solve. So let's try one with the square root property. See how this is a perfect square? And this is a perfect square also? We're going to use square root property, which is the square root of both sides. So we would have y minus 6, because the square root of y minus 6 squared is going to be y minus 6. And what's the square root of 81? 9, and there's another one, negative 9. Any perfect square of a number will have two results, a positive and a negative of that number, because I can take negative 9 times negative 9 to get 81. So I have two separate equations to solve now. I add 6 here, and I get y equals 15. I add 6 here, and I get y equals negative 3. So fat man bracket, negative 3 and 15 are my solutions. And that was a little bit easier than having to factor anything. You just use square root property to solve both sides. Let's try another example of that. This is a perfect square. Now this one is not, but you can still use square root property. Square root both sides, and you have x plus 6, because the square root of x plus 6 squared would be x plus 6, is equal to, what is the square root of 12? This is not going to work out and to be a whole number, so I would say go to the nearest hundredth, which would be 2 decimal places. So I'm going to do radical 12 on my calculator. And this is going to be x plus 6 equals positive radical 12, and x plus 6 equals negative radical 12. So I'm going to subtract 6, and x equals negative 6 plus radical 12. And when you do that on your calculator, go about 2 decimal places. So if you subtract 6 from that, you get about negative 2.54. And you could try it on your calculator and see if you agree there. Subtract 6 here, and then we do x equals negative 6 minus radical 12. So you're going to take radical 12, and then you have that going to be more negative, so you're going to add those two together, and you get approximately negative 9.46. So you can have a whole number result like you did here, or you can have decimal results where you'd have negative 9.46 comma negative 2.54. When you're working with radicals, if you want to solve it from the very beginning and just have your positive and negative result from the very beginning, you can, or you can leave it in radical form until the very end like I did, and then you could just find your radical 12 and then add your negative 6, find your radical 12, subtract your negative 6. Whichever you prefer is fine. So you try the example of the square root property in your notes. What you're going to do with the real world problem today, we'll solve it in class tomorrow, but I want you to get started on it. This is from physical science, which is the science class that you will take next year. So during an experiment, a ball is dropped from a height of 205 feet. The formula, h equals negative 16t squared plus h to sub 0, can be used to approximate the number of seconds t it takes for the ball to reach height h from an initial height of 0 feet. Find the time it takes the ball to reach the ground. I will set it up for you in your notes. I want you to give it a try to see if you can balance it, and then we'll talk about it more in class tomorrow.